Hey guys, this is Drew, the SDSU EE tutor, and in this video we're going to take a look at functions. More specifically, we're going to take a look at syntax and returning of functions. So let's get started. First, let's take a look at our main program. So the function we're building is called addUs, right there, addUs, and the second function is called printing function. Right, but we're going to be concerned with addUs for the first portion of the video. First off, we declare three variables, a, b, and result, and they're all of type integer. Notice that when we declare these variables, you always set them equal to 0. The reason you do this is because if you just say int a and int b, these are both perfectly valid statements in C, except when your computer creates these variables, they're just going to be equal to whatever junk is already stored in memory wherever your computer decides to put A and B. So let's see what I mean by this. Okay, so if you look at the cursor, I've already executed this int A and int B. And if you look these up in memory, right, so A is equal to 430000 right here, these four. And B is equal to 683C6600. Right, so this is just the junk that was stored in memory previously from whatever program was running. So rather than have random numbers stored in memory, you want to have it equal to something, whether it be 0 or some number that you establish. So let's set them equal to something. Close that. This will equal 0. This will equal 0. Let's rerun debugger. Next line, next line. Right, so now you can see if you look in memory, this has changed, right? B is now equal to 0, and A is now equal to 0. So it's something that's just good programming practice. It's not mission critical, but it can save you lots of time from debugging if you're getting weird numbers in your program. Alright, so we created three variables. We tell the user enter two numbers, then we say number 1, and we use scanf to take in that input. And taking a look at scanf, notice the syntax of this. %d, right? So this tells scanf that we're going to be accepting a decimal or an integer, and then comma, ampersand a. We are telling scanf that we want this number stored in the address of A. And then we print to the screen, ask for number 2. And then we receive number 2 and store that in B. We'll say result equals our function addUs. And then we'll say your answer is, and we'll print out the result. And just to check, we'll print out this last line and say, thank you, your function works. Right, and lastly, we have this function called printing function, and we'll take a look at that in a second. Let's take a look at this line right here. Result equals addUs. Right, and addUs takes in A and B and adds them. But notice that this variable is equal to this function. Okay, result is going to be equal to whatever addUs returns. Okay, so this is why return values are important. Now let's go up here. So function prototypes. Function prototypes tell us the type of function, this is an int, the name of the function, and the types of any parameters that you pass in. So why do we have these? Let's say we didn't have function prototypes. Okay, our function definitions are down here, right? This is where we say what is addUs and what is printing functions. And if we scroll up, that is after our main program. So when your computer tries to read this, it's going to say, okay, A, B, result, run through this, scanf, printf, scanf, and then boom, result equals addUs. It will hit addUs and it'll be like, what the heck is this? Because addUs comes after your main function, it's not going to know what it is or what to do. So by declaring a prototype, you say, hey, there's a function called addUs, and when you hit it in your main program, don't worry, it's written somewhere else in the code. Right? As well as you have to know the data types so that when you're creating the program, the computer can allocate the correct amount of memory. Now let's take a look at the definitions. For the definition, you have to say the data type, the name of the function, and the data types and names of your parameters. Notice that in your definition, the name of your parameter does not have to be the same as the variable that you pass into it. Up here it's A and B, and in our definition the parameters are X and Y. Right? So for when you're creating the definition, this X and this Y is only relevant to what you write in the definition. When we get to our main program and you pass in A and B, what's going to happen is it's going to say, okay, A is going to be X, B is going to be Y, and then we'll run this function. And then we say we create an integer sum, set it equal to 0, sum equals X plus Y, and then we return that sum. Realize, returning, this is very important. The number you're going to return should be of type int. Right? You said addUs is of type integer. So because you already declared this, that's what it should return, which is why sum is also an integer. So realize, return values and whatever you declare the function to be should match. Okay, now let's take a look at printing function. Right, so this whole thing of return values, a return value makes sense for addUs. Right, we're setting result equal to this, and then addUs should return a value that will be result. But what happens if you don't need a return value? Right, and in the case where you have a function that doesn't need to return value, aka you're not doing math or working with numbers, then you can declare a function to be void. Okay, you have a void function when you do not need to return something. And simple case of not needing to return something is just printing lines to the screen, right? You don't need to set anything equal to a return value. You can just declare it void. So because in printing function, all we're doing is printing 3 functions, you can just say void, and you don't have to say return anything. So those are our functions, and let's take a look at this works. So 2 numbers, 10, 25. Sweet. And we're all good. Thanks for watching, guys.